All right, we're going to look into the mechanism in a little bit more detail. All right, and first one going to be the stereochemistry of hydrohalogenation. Let's see what happened. All right, so if you draw the mechanism, so nucleophilic attack on the hydrogen. So the carbon with the less substitute carbon will form bond with the hydrogen. Okay, and leave the carbon in the middle right here, become positive charge, which is the carbocation. Now, if you still remember that carbocation is flat, right, and got a space at the front, at the back, or top, or the bottom, depends on how you look at it, which means that bromine can attack from any direction there, from the front or from the back. That's why you're going to get both wedge and dash line, the enantiomer product. Okay, that is stereochemistry of a hydrohalogenation. So if you still remember in chapter 7, if you see a carbocation, there are two events that could happen, right? So we have racemization right here. This is racemization. You get an both pair of enantiomers in an equal amount, right? Or rearrangement. Let's take a look at the new one. Okay, this one is a rearrangement. All right, take a look right here. So hydrochloric acid react with this. So it's the chlorine supposed to be added onto this carbon, right? But it's only 50%. You get R and S, you know that? But the major product is where chlorine add on to the more substitute carbon. This guy not even have a double bond, you know that? But how that happen? Well, the rearrangement, the hydrogen shift here. Let's take a look. All right, nucleophilic attack. All right, so lead carbon in the middle got become a carbocation. Chlorine attack there, so you should get two products here, right? One is wedge, one is dash. That's all this, but it's only 40%. The major product right here, hydrogen shift, right? Secondary carbocation go to tertiary carbocation, which is more stable, and then chlorine attack, right? In this case, you get only one product, not two, because this carbon here is not a stereo center, not a chiral center. Two methyl group right there, right? If you still remember the the definition of chiral center is a carbon with 4 different substituents. There's a 2 methyl group there, not 4. All right. All right. Another type of rearrangement, right? This is an alkyl shift. This one, it looks like the ring is ring expands, right? So we call ring expansion from 4-membered ring to 5-membered rings, but there are 4 of them right here. This is the product there, all right? But we're gonna get all this. Just don't look at that, right? But how are we gonna get to this? Let's take a look. All right, just draw the mechanism as usual. Nucleophilic attack, or you get a carbocation right there, which is really unstable, all right? Can you make it stable though from secondary to tertiary? There's no you cannot use hydrogen on here. Otherwise, you have what's that? Primary carbocation, right? On the left side, there's no hydrogen, but we have a methyl group right here. We have all the alkyl group right here, right? So you can do alkyl shift, that could happen, right? Or you can move this carbon up to there. You get 5-membered ring from 4. The product say that you get 5-membered ring products, right? So this is 4-membered ring. You have to make it 5 or ring expansion. So we do alkyl shift right there. Okay. So this carbon right here will form bond with the carbocation right there. So look at right here, you know that? And the quaternary carbon down in the middle right here will become a carbocation, you know that? All right. One thing you should know, and I'm sure you know it already, a carbocation is flat, right? Which means that the nucleophile can attack this carbon from the top face, from the bottom face. If this guy attack from the bottom, the methyl group will get pushed up. Look like that. That is an SN2 basically. If this carbon attack this carbocation from the top face, this methyl group will stay down there. Yeah. So all right, I'm gonna draw a bond line structure. So you should get up and down. Yeah. This carbon here, this carbon there, this carbon here, this carbon there. All right. And then chloride can attack this carbon here from the top face and the bottom face. You get chlorine at the top, chlorine at the bottom. Same thing down here. Chlorine can do the same thing, attack from the top, attack from the bottom. So chlorine up, chlorine point down. So 4 5-membered ring products. All right. So when you see a carbocation, every time racemization, is it possible? And rearrangement, so be careful on those. Okay. All right, let's go to the second reaction.